Welcome to the first topic of AQA GCSE Physics, Energy Stores and Systems. Right, so this topic is really fundamental to understanding physics, the concept of energy. And so what we're going to be doing basically today is defining systems, what energy conservation is, and describing how energy moves between different stores. But in this particular first section, there's no mathematics going with that. We're just going to have to be able to describe how, when any system changes, how the energy moves from one store to another. Our videos are not just a series of facts, they're designed to help you think, help you remember the concepts as you go through the GCSE Physics course. So the first thing we're going to do is get you set up on how do you remember all the definitions. So what we're going to do is create a set of flashcards now that you can add to as you go through the videos. I'll tell you also how to best use these to help you remember all the definitions, all the equations, all the units, or what we call the AO1, the recall of facts and knowledge in isolation, which represents 30 to 40% of your GCSE. How are you going to do that? And so the first thing we're going to do is create a set of flashcards. So to create your flashcards, all you need is a sheet of paper and a pair of scissors. Okay, so what you're going to do, fold the piece of paper like so. Okay, fold it over again. This is an A4 sheet of paper. Okay, and then fold it over one final time. So this strategy works with any subject you've got to recall information for. Okay, ideal for definitions. Okay, so that's given us a sheet of paper into 8 definition cards. So what we can do then is cut along here.
Now that you've got your flashcards, we're going to use them to learn our first definition, which is a system. So right on here, define a system.
Now a system is just an object or group of objects. Now, what do we mean by that? Well, really that means a system can be anything you're studying. So it could be a cup of tea cooling down on a table, it could be a ball being kicked into the air, it could be a bungee jumper jumping off a bridge, it could be the earth as it travels around the sun, okay, a car putting its brakes on. Whatever you're studying, whatever the situation the exam question is asking you about, that is the system. Next thing you need to know is that whenever a system changes, there are changes in the way energy is stored. So what do we mean by that? Well, okay, so take the bungee jumper jumping off the bridge. Well, when he's at the top of the bridge, the energy he's got is in the gravitational potential store. Then, as that person jumps off the bridge, they lower their store of gravitational potential energy, and that energy goes into a different store, which is the kinetic store. So what we're going to have to do is describe how the energy can be stored and how it can move between these different stores. The next key idea that you need to know is the law of conservation of energy. Now this has been described by some physicists, including one of my favourite physicists, Richard Feynman, as the most fundamental law that humans have ever come up with. So if we lost all our information in some sort of disaster, the one thing we would need to store and remember would be the law of conservation of energy. So the next definition is define the law of conservation of energy. Right, the definition of this is that energy cannot be created or destroyed, only transferred usefully, stored or dissipated. Energy cannot be created or destroyed, only transferred usefully, stored or dissipated. Now we talk about these terms a bit later on about which stores they're going to be can be in, and what does energy dissipation mean? But dissipate just means spread out, really, and essentially become less useful as it spreads out more and more. The next fact we need is the SI unit for energy. SI just stands for Standard International Unit. So the fact that all countries use these same units for this. So I'll put in here that that is joules, capital J. Okay, now that's all you really need to be able to write, the capital J. A lot of people will lose a mark for putting a little j instead of a capital J. That's what you need to put if the units. So a question might say, and state the units, and you just put 45, say, joules with a capital J. That's all, just a symbol. So you only need to use the symbol capital J. 1 joule is about the energy of lifting an apple about 1 metre off the ground. If I lift this up, that's 1 joule of energy. I've just lifted that apple through. You need to be able to apply the principle of conservation of energy to a closed system. So we need to know what a closed system is. So we're going to use one of our revision cards to note the definition of a closed system. A closed system is one in which there is no net change to the total amount of energy. So in other words, the total energy stays the same. This might seem a little bit tricky, but essentially whatever system you're studying will be a closed system, so there won't be any energy coming in or out of it. We'll now have a look in detail at one example using a cup of tea in the room as our closed system and look at the energy transfers there. We're going to apply conservation of energy to our system. So our system is going to be really simple. It's a cup of tea, hot cup of tea, and the surroundings, which will be the desk and the air in the room. So our system very simply comprises of a cup of tea and the surroundings. Okay, if we call it a closed system, that means there's no energy coming into that system or out of it. So let's add some energy in. Now, one of the greatest physicists of all times, Richard Feynman, suggested we just thought of energy as blocks. Okay, so we've got to use these Duplo blocks here. So we count each one of these, say, as a joule of energy. So we've got 10 blocks. These 10 blocks will always be in the system, either in the cup or the surroundings, but no extra can be added in. We can't get 11 blocks, we can't lose any blocks, we can't go down to 9. There's always 10 blocks of energy, 10 joules of energy, if it's a closed system. So let's start off and put, because the cup's hotter, I'm going to put some extra energy into there, and you can see these two, there's less energy here, more energy here. This is the starting position for our system. And we're going to do loads of examples of these throughout the next videos, okay, through the worksheets, if you're following along with those on the website. Over time then, energy moves from the thermal store of the tea, the thermal store of the cup, to the thermal store of the surroundings. Now in actual fact, we're doing it neatly into here, in that this bar chart, the amount of energy in the surroundings is going up, the amount of energy is going down in the cup. Okay, so over time it starts dissipating. So dissipating basically just means that this energy actually will just be spread out around the room. Okay, so overall we've still got our 10 blocks, but you can see that energy is moving to different stores. Okay, but remember, the concept of this closed system means we can't get 11 blocks, can't get 9 blocks. We've always got 10, they just move from one store to another. So what we really have to look at now then, to explain any situation, this is the concept. The energy just moves from one store to another. So you now need to learn what the different stores are and then how the energy can move from one store to another. So just recapping, started off in the thermal store of the cup and moved to, by heating, to the thermal store of the surroundings. Okay, so whenever there's actually a temperature difference between objects, energy moves from heating, by heating, from the hot object to the cold object until they're actually in thermal equilibrium, which means that they're the same temperature. So both of these would be room temperature, which would be 20 degrees, and then there would be no net change of energy between them then.
So just recapping after this first lesson, we know what a system is, we know the principle of conservation of energy, we know the units of energy, and we know what a closed system is, and we've looked at some examples of that. What you should be able to do now is complete the worksheet for this section and have your list of revision cards so you can remember this AO1, these facts and definitions. So next lesson we'll look at the different stores.